In this 3-part tutorial about the controversial negative harmony theory, you'll learn all this discomposition tool to write unique and remarkable variations of your existing musical ideas. In part 1 we have seen the origin of negative harmony, and we started with melody inversions to understand the principle of negative harmony. In part 2 we have seen that negative harmony uses a specific axis for mirroring the notes of a melody, and in particular the notes of a chord, for a transformation into a negative counterpart. Now we took the theory to the test and transformed real music into negative harmony. Now in this part 3 we're going to look at the brightness and darkness of modes of the major scale and the way negative harmony transforms these modes. And we'll see the difference between modal interchange or modal mixture and the negative harmony theory. So buckle up for the last part of this tutorial. If you missed part 1 and 2, then I suggest you watch those tutorials first. Still, here's a short recap. Negative harmony is sprouted from the brain of Ernst Levy and made popular by Jacob Collier. It all boils to this. Every chord has an emotional and harmonic opposite that can be found with the negative harmony theory. It mirrors the notes around a specific axis that lies between the tonic and the 5th degree, or to be precise, between the minor third and the major third of a major scale. We can use the circle of fifths or the chromatic circle to visualize the transformation of each note in the major scale. And we will see that in this way the major scale is transformed to a minor scale. To transform a chord, we must individually transform the notes of a positive chord, creating a new chord which is the harmonic and emotional opposite of that positive chord. Major chords become minor chords and the other way around, and the tonic changes too. Diminished triads are transformed into another diminished triad. So with negative harmony, we transform a dominant cadence G7 C major to a plagal cadence F minor 6 C major. And important to know is that the gravity to the tonic of both positive and negative chord G7 and F minor 6 is the same, yet the emotion is different. Now I believe it was Adam Neely that once introduced the Dorian Brightness Quotient, which is a tool to compare heptatonic scales, and those are scales with 7 notes, regarding brightness and darkness. The Dorian mode is the most neutral of all and serves as a benchmark or 0 point. And we will need the Dorian Brightness Quotient, which is abbreviated to dBq, to better understand negative harmony of modes. As I have indicated in the previous part 2, modulating to keys clockwise in the circle of fifths brightens the sound. More sharps or less flats tend to brighten the sound. Modulating counterclockwise in the circle of fifths will darken the sound. More flats or less sharps tend to darken the sound. The Dorian Brightness Quotient is an integer value that can be positive, negative or 0. The value of the dBq is determined by the number of raised or flattened notes compared to the Dorian mode. The more raised notes, the higher the value of the dBq will become, and the more flattened notes, the lower the value will become. So if we take an A Dorian scale that has 1 sharp, then we could say that the A Lydian scale with 2 sharps has a dBq of 1. It has 1 sharp more than the benchmark scale A Dorian. If we look at all the modes starting on the tonic A, then we'll see this. And by the way, I'm using the tonic A because then we have modes with sharps and flats, and that makes it easier to explain. The A Ionian mode has 3 sharps. The A Dorian mode, the second mode of G major, has 1 sharp. The A Phrygian mode, the third mode of F major, has 1 flat. The A Lydian mode, the fourth mode of E major, has 4 sharps. The A Lydian mode, the fifth mode of D major, has 2 sharps. The A Aeolian mode, the sixth mode of C major, has no sharps or flats. The A Locrian mode, the seventh mode of B flat major, has 2 flats. Now we can rearrange the modes on the tonic A according to the number of sharps and flats, like this. A Lydian has 4 sharps, A Ionian has 3 sharps, A Lydian has 2 sharps, A Dorian has 1 sharp, A Aeolian has no sharps or flats, A Phrygian has 1 flat, and A Locrian has 2 flats. Now we'll put A Dorian in the middle with a dBq of 0. So the dBq of every mode will be like this. Lydian is 3, Ionian is 2, Lydian is 1, Dorian is 0, Aeolian is -1, Phrygian is -2, and Locrian is -3. And this is also apparent in the circle of fifths, where we can see the tonic of a key as a mode of the C major scale. F Lydian, C Ionian, G Lydian, D Dorian, A Aeolian, E Phrygian, and B Locrian. Now D Dorian will have a dBq of 0, so we can fill in the rest. You can use this system when you want to change the mood of your composition, for instance. But more important is that there's a hierarchy in modes regarding brightness and darkness. And we'll see this again in one of the next chapters. Now next we're going to see what happens when we transform all the modes of the major scale into negative harmony. We have already seen the order of brightness according to the dBq, so let's start with the brightest of them all, the Lydian mode. A, B, C sharp, D sharp, E, F sharp and G sharp. If we transform the notes according to the circle of fifths, then we create an axis between the tonic A and the fifth degree E. A becomes E, B becomes D, C sharp becomes C, D sharp becomes B flat, E becomes A, F sharp becomes G, and G sharp becomes F. The tonal center should be A, so the resulting negative scale is A Phrygian. So Lydian becomes Phrygian and Phrygian becomes Lydian when subjected to negative harmony. The A Ionian mode is transformed to the A Aeolian mode. A becomes E, B becomes D, C sharp becomes C, D becomes B, E becomes A, F sharp becomes G, and G sharp becomes F. The Mixolydian scale is a major scale with a minor 7th degree. When we subject this scale to negative harmony, then we'll see that A becomes E, B becomes D, C sharp becomes C, D becomes B, E becomes A, F sharp becomes G, and G becomes F sharp. The resulting scale is a Dorian scale, so Mixolydian is transformed to Dorian with negative harmony, and of course the other way around. We have one scale left, and that's the Locrian scale. Now the Locrian scale is a bit of a problem because of that diminished fifth. The Locrian scale sounds quite weird to our ears, and the scale is rarely used for creating a song, but much more as a scale to play over a specific chord while improvising, for instance. But if we do transform the A Locrian mode, then we'll see this. A becomes E, B flat becomes E flat, C becomes C sharp, D becomes B, E flat becomes B flat, F becomes A flat, and G becomes F sharp. If we arrange the notes to become a mode, then this would be again a Locrian scale. It's the B flat Locrian scale or the A sharp Locrian scale. So negative harmony reflects the notes of a Locrian scale to another Locrian scale that is a half step higher. So summarizing, we have seen that negative harmony works like this on modes. Lydian becomes Phrygian, Ionian becomes Aeolian, Mixolydian becomes Dorian, and Locrian becomes Locrian. Well, more or less. So how does this all translate to real music? I mean, let's be honest, such a theory must translate into emotions, right? Otherwise it's merely numbers and science. Now to demonstrate this, I took a song that I didn't know of before I was doing this tutorial. I was just searching for a song in the Lydian mode to demonstrate negative harmony with modes, when I came upon this beautiful progressive rock song from the 80s. It is the song Freewill by Rush from the album Permanent Waves, and it marked a new era in the direction the band was going, more progressive. Now the song is obviously written in F Lydian, but I transposed it to E Lydian to make it easier to work with. The theme of the song sounds like this. The E Lydian scale looks like this. It is a major scale with an augmented 4th degree A sharp. The chords in the scale are the same as those found in B major because E Lydian is the 4th mode of the B major scale. So E major, F sharp major, G sharp minor, A sharp diminished, B major, C sharp minor and D sharp minor. If we analyze the song, then we see an intro that uses 2 simple Lydian scale figures with a syncopated bass line that doubles the kick drum and outlines the power chord of the tonic E major. In the next 2 bars, in an odd time signature, the guitar plays a bass line that suggests the tonic E major and the 2nd degree F sharp major. Now these 2 chords are often used to outline the Lydian mode. In the next two bars, the guitar part of the previous measure is played by the bass guitar, while the guitar plays 3 triads in the Lydian mode. So, how can this be treated with negative harmony? Well, you will see that this is actually straightforward. Well, we already know that the negative harmony opposite of E Lydian is E Phrygian. And E Phrygian is a minor scale with a characteristic minor second degree. So we'll go from super bright to pretty dark. The scale figures of the intro will be transformed using the right axis that is visualized by the circle of fifths. Or you can use a grammatic circle, whatever you feel that is most convenient for you. So, E becomes B, F sharp becomes A, G sharp becomes G, A sharp becomes F, B becomes E, C sharp becomes D, and D sharp becomes C. If we project this on the scale figures, then we'll see this transformation from Lydian scale figures to Phrygian scale figures. The bass line is not a melody, but it suggests an E major chord in the form of the tonic and the fifth of the chord, a power chord. Now we should treat this bass line as a chord. E major becomes E minor, so we should keep the bass line as it is. The chords in the scale are transformed too, as we have seen in part 2. We'll use the circle of fifths to find the new root, like you see in this figure. Now, besides the conversion of root notes, we also have to change major to minor and vice versa. The diminished chord becomes again a diminished chord. So, E major becomes E minor, F sharp major becomes D minor, G sharp minor becomes C major, A sharp diminished becomes B diminished, B major becomes A minor, C sharp minor becomes C major, and D sharp minor becomes F major. The guitar plays a line in the next two bars that outlines the tonic E major and the second degree F sharp major. If we strictly transform the notes with negative harmony, then we have created a line that outlines the negative opposites of the E major and F sharp major chord, namely E minor and D minor. These chords are the tonic and minor 7th degree of the Phrygian mode. Now these chords outline the E Phrygian mode perfectly. The next two bars contain triads in the Lydian mode, E major, F sharp major and B major. The tonic, the 2nd degree and the 5th degree. Now the chords are transformed to respectively E minor, D minor and A minor. And this has a huge impact on the sound, of course, because a riff with only major chords becomes now a riff with only minor chords. So the positive and negative version of the great song Freewill by Rush sounds like this. In the example, we use the brightest mode to transform into the second to last darkest mode. The difference in sound is of course significant. Other modes and their negative counterparts have less difference in bright and dark, but are still very nice to use. Just experiment with these modes and their negative counterparts to find new sounds and contrast in your own music. Now, before I end this tutorial, I want to have a quick word about modal interchange versus negative harmony. Negative harmony is controversial. Some people would say that negative harmony is not worth the fuss because it is the same as modal interchange or modal mixture. Well, I'm sorry to say, but that is not the case. No, I'm lying. I'm not sorry. See, when we do a modal interchange, we borrow chords from another mode, and most likely the Aeolian mode, which is the minor scale. So in C major, we borrow chords from the C minor scale. Instead of playing C major, F major, A minor, G dominant 7, C major 7, we could play C major, F minor, A flat major, G dominant 7, C major 7. Also, the melody will be adapted just by raising or lowering a few notes to fit the new chord that is underneath the melody. But with negative harmony, the notes of the chords are transformed by mirroring them over a specific axis. The chords will change much more, as we have seen in this lesson, because the root changes too. The F major chord becomes a G minor chord and the A minor chord becomes an E flat major chord. And this will sound different. Also, the melody is now completely mirrored over a specific axis. And the result is another sound completely. So everybody knows this next great song that I will use for my demonstration. It is Twinkle, Twinkle, Little Star. Now first listen to the melody as it is. Change with modal interchange. It sounds different, but not too drastic. But subjected to negative harmony, the sound changes completely and gets an exotic or even Eastern European flavor. So, is modal interchange the same as negative harmony? The answer is no, it is not. So after these 3 videos about negative harmony, what can we conclude? In other words, what did negative harmony do for us lately? And that is a reasonable question. Because like with any other theoretical concept, it is either to understand a certain musical phenomenon, or it is to create music according to that theoretical concept. Or, and probably both. Anyway, with negative harmony we can alter existing music to an emotional opposite. It is strongly pointed at harmony instead of melody, but both can be transformed as we have seen in part 2 and 3. In this part we have seen that negative harmony works for modes too. And there can be said much more about negative harmony than I have said in these 3 lessons, but with the things you have learned, you have a good understanding of negative harmony and it won't be such a mystery anymore. So thank you Patreons, thank you subscribers, thank you viewers, thank you all, and bye.